Students, good morning. Today we are going to continue our lesson scientific study of grade 9, about which we have studied many things. Today is the last lesson of this unit. Before it, we did about metric prefixes and we did some exercise also, but that was not enough. And as it is very important, think for your other lessons also when you are doing numerical problems, when you are converting one type of unit into other type of unit. So for that, you must have a clear-cut concept about prefixes, their values, and their transformation from bigger to smaller and then smaller to bigger. That's why today again we will repeat little bit and we will do some new types of exercises to have the concept of metric prefixes. After that, we will discuss about least count and average measurement. Okay, they are the last subtopics of the unit. Okay, so at first, we are going to start our class by one activity. For it, you must have your scale. Your instrument box should be in the side of you. If you don't have, please bring it. Bring your instrument box and take out scale and protector from it. Okay. But before that, you have to keep with you, because later we will need to use them. At first, I am going to repeat the last terms which was related with metric prefixes. And if you remember, I told that you can memorize at first the fundamental prefixes. Main units may be meter, maybe gram, maybe liter. And after that, you have to know prefixes. We have to add prefixes with these units. So smaller prefixes, just greater than main unit, that is deci, then centi, then milli. And below it, that means below main unit, which is greater than it. Below means not by its value in the table. We show below, bigger unit is shown below. So below main unit, we have to write deca, then hecto and kilo. So you can memorize them from milli to kilo in this way: milli, centi, deci, main unit, deca, hecto, kilo. So see about these prefixes and their units once again: milli, centi, deci, main unit, they are meter, gram or liter, then deca, hecto, kilo, then there are some bigger also about which I am giving at side. Look here: pico, nano and micro. They are smaller than milli. Okay, and here why I am writing inside, last time also I told you, bigger than kilo, they are mega, giga and tera. So here milli, at first you have to remember the values also. Milli, symbol m and its value is 10 to the power minus 3. Centi, c, small c, you have to care capital and small letters also. Centi, small c, and its value is 10 to the power minus 2. Deci, small d, its value is 10 to the power minus 1. And after that, their value is 1. And 1 meter, 1 gram, 1 liter, so on. And deca, capital D or small da. Small d, small a, or capital D only. Deca, that is, its value is 10. You can say 10 to the power 1, meaning is same. So 1 in power is not written. Hecto, H, and its value is 10 to the power 2. That shows that 100 times bigger. And kilo, symbol K, that is small k. Remember, here deca, capital D, but hecto and kilo, small k. And their value are 10 to the power 2 and 10 to the power 3 respectively. And smaller than milli, 1000 times smaller, micro. And it is shown by mu. Mu, yes, you are familiar with that symbol, mu, which is used in wave equation also. Yes, wave velocity equals mu into what? Lambda. Yes, you did. Okay, in class 8 also you have done. So that is mu. Here mu is used for micro, its value is 10 to the power minus 6. Nano, small n, 10 to the power minus 9. Pico, p, 10 to the power minus 12. And here bigger than kilo, mega, capital M, 10 to the power 6. Giga, capital G, 10 to the power 9. And tera, capital T, 10 to the power 12. So not only that, there are some bigger also. I told you after tera there is peta, 10 to the power 15, exa, 10 to the power 18. Like that, smaller than pico is femto, F-E-M-T-O, femto, and its value is 10 to the power minus 15. And smaller than femto is atto, 10 to the power minus 18. But they are not in our use, that's why I am not introducing here. Okay, so you can memorize in this way: milli, centi, deci, main unit, deca, hecto, kilo, and then smaller than milli, micro, nano, pico, and bigger than kilo, they are mega, giga, and tera. Yes, so upper three and uppermost, the three prefixes given at the uppermost and three prefixes given at the lowermost here, which is given here side. So they have the difference of 1000. Here it is 1000 times different from that one, and like that the relation is same with others. Here also the difference is of 1000. Okay, so you are familiar with it. Now here same table I am giving once again, but some new things I will introduce you, that from pico to deci, which are smaller than main unit, they are some multiples. And the units from deca to, that means units, I can say prefixes which are used for unit. The prefixes from deca to tera, they are multiples of main units. If you are saying that 1 decameter, that will be 10 meter. If you are saying 1 kilometer, that means 10 to the power 3 or 1000 meter. Okay. If you are saying 1 micrometer, 1 micrometer means 10 to the power minus 6. That means 10 lakhs times smaller than the main unit. 10 to the power minus 6 meter. If 1 meter is divided into 10 lakhs part, then one part will show 1 micrometer. Yes, like that. That is the relation. So if you are changing one type of unit into other type of unit, what things you have to keep in your mind? Yes, for that you have to see these points. For the conversion of units, at the first step, the unit should be changed into main unit. Why main unit? If you are changing nano into kilo, you cannot go directly. At first you change here. That means if nanogram into kilogram, then at first change into gram, and then only you try for kilogram. Okay. While changing bigger unit into smaller, the positive index value of the prefix is multiplied with the unit. Doesn't matter its value is given in minus, but if you are changing smaller into bigger, then this power will be used positive and this number will be multiplied with the unit given here. If you are changing bigger into smaller, then if you are changing smaller unit into bigger unit, then you have to use the power value negative. Okay, that means you are dividing now. In both cases the process is multiplication, but one with positive power, another with negative power. If you are multiplying with positive power, that is really multiplying, and if you are multiplying with negative power, then that will be division. Yes. So here I am not using that you have to multiply or divide. In all cases you have to multiply, but smaller into bigger, if you are changing, then you have to use negative index, negative power. Here it may be in positive, but while changing smaller into bigger, then you will use negative power. Last time we did. Yes. So by using here, we will do some exercise, only few, but and another thing with power of, that means there will be power in unit also. That was not done. Okay, students. So we are going to practice some conversion of units. So I am going to start from very simple example. Consider it is example, one example. First example number 1. consider you are changing 1.6 into 10 to the power 3 meter into centimeter. Then how will you change it? You can change it very easily because you have already practiced it. 1.6 into 10 to the power 3, and then you have to write the value of centi, but value of centi is that, but you are not going to use negative power because bigger unit is going to be changed into smaller. So use positive power. Yes, and that will be centimeter. After that, here 1.6 into 3 and 2 will be added. So it will be 10 to the power 5 centimeter. So easily you can change it. Now next example, just discuss about it. It is little bit complex. Consider 2.5 into 10 to the power 6 meter square has to be changed into centimeter square. Then how will you do it? It is different. Yes. In that case, don't be confused. You have to make a square of that value. Only that you have to change. So 2.5 into 10 to the power 6 into 10 to the power, what is the value of centi? Minus 2. But we are writing here positive 2 because bigger unit is going to be changed into small unit, into again 10 to the power minus 2, but in positive, not minus 2, 10 to the power 2, and that will be 2 point. Here also you can write centimeter square. After that, 6 plus 2 plus 2, that is 10. 10 to the power 10 centimeter square. Yes. Okay. And here we are changing bigger into smaller. Now we are going to change smaller into bigger, but in cubic meter. Yes. Okay. So see next example number 3. After that you can practice yourself, doesn't matter. Example number 3, and here you are given 3.5 into 10 to the power 5 centimeter cube into decimeter cube. You have to change. Look, little bit typical also. You are not going into meter cube, but to change into decimeter cube also, you have to go at meter cube at first. At first, you have to go up to what? That main unit. So how will you go there? If you are changing centimeter into meter at first, then only decimeter. Changing centimeter cube into meter cube, that means you are changing a smaller unit into bigger unit. Yes. So it will be 3.5 into 10 to the power 5. Then into, what is the value of C? 10 to the power minus 2. And how many times? 10 to the power minus 2, 10 to the power minus 2. Or you can write here 10 to the power minus 2 plus minus 2 plus minus 2. Same thing. Yes, if you understand. If you have understood this fact, you can write in one step also. Doesn't matter. But at first understand. In that condition, what will be, okay, if you are writing that, it will be meter cube, not decimeter cube, meter cube. What will you get? 3.5 into, it is 5 and it is minus 2, minus 2, minus 2, minus 6. So 10 to the power minus 1. How? Minus 6 plus 5. So what will you get? Minus 1. 3.5 into 10 to the power minus 1 meter cube. And here, it is not your target. Your target is what? Decimeter cube. So to reach up to that, you will do some more steps. 3.5 into 10 to the power minus 1 into 10 to the power, again, value of deci. What is the value of deci? 10 to the power minus 1. But you are going to change bigger into smaller. So that minus will not be written. So it is not necessary to write 1. Doesn't matter if you are writing. It will not affect on this value, only that. If you are writing, that's okay. 10 to the power 1, 10 to the power 1, 3 times, because there is cube. And then only it will be what? Decimeter cube. After that, 3.5 into 10 to the power minus 1. So here, minus 1 cancel. You have 10 to the power 2 decimeter cube. So like that, you will practice some more things related to it. Okay? Okay. After that, your scale and protectors are required. So take out from instrument box. And here, after one step, I will use it to use that scale and protector. At first, here I will show you some devices, and these devices in diagram only at first we will see, and you will find out that what is the minimum value we can measure by using it in this diagram. I think it is clear. That is ammeter, it is also ammeter, it is also ammeter, but the values given here are not same. Values measuring by them, the least value means the minimum measurement you have to find out. If pointer comes here, then it measures 1 ampere. But there are division also. So you have to find out. Can you get how many small divisions are there? I am seeing here there are 10. So 0.1 ampere. Yes, you are correct. And here, what is that? It is from here to there 5 ampere. So how many gaps are, that means how many segments are there? 1, 2, 3, 4 and then 5. So here one segment shows what? 1 ampere. You cannot measure smaller than 1 ampere here. And here 1 to what? That is given. How much? 0. What is it? You can see clearly. Can you see it? Okay, so you can see that here it is given 0.2 ampere. It can measure smaller, and not only that, count this gap, this segments. So they are 10. So 10, again, if you have to make it smaller, then that will be what? 0.02 ampere you can measure by using this device. So here you have found another concept that different measuring instruments have different minimum measurement given by them. Okay, and the minimum, what does the minimum measurement call? Later we are going to be familiar. So that is, term is given at the top. The smallest measurement that can be taken by any measuring instrument is called the least count of that instrument. So we have found that least count of these 3 devices measuring same unit, same value, current, electric current, was different. Yes, and here the least count also varies according to the measuring instrument already given. Next thing, the importance of least count is high. In scientific measurement especially, that least count is required sometimes for particular example. Last time I told you that because of fraction of seconds it was late to supply water into nuclear power, by which the nuclear accident took place. Little bit late, in fraction of second, because during that time the reactor was overheated and it busted. It burst. Okay, so there is, for different events there is different value. By using it, we can make accurate measurement, collect and analyze accurate data to reach the correct conclusion. Yes, so least count is very important in scientific measurement. Okay, students, after that you have to take out your scale and you have to study in it also. So, here in diagram also and real operators also I will show you. So, here is I have one scale, you also take out from instrument. So, here at upper surface this line you can say some value, and that is, look here in your scale there is given centimeter, yes, and down it is different unit, that unit is about inch, yes. So, what is the minimum measurement in centimeter or some other units? That means in meter, fundamental, or you can say the basic unit is meter, but with prefixes, what is the minimum value you can measure by using it? And then in this scale, what unit you can measure, you find out, that means the minimum value. You have to find out least count. Okay? Okay then. So, you can see it in diagram also. So, here if you are seeing that upper one which is given, it is 1 foot long, I can say 30 centimeter long scale, and gap you can say that from 5 to 6 you have to count the numbers. You have to count the numbers. So, numbers of segments. So, it is clear 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, there are 10 segments. So, 10 part of 1 centimeter, what is it? Smaller than centi. Yes. So, that is what? Millimeter. So, you can count, the least count of this scale is 1 millimeter. And here how many segments are in between 2 and 3? It will be little bit difficult. Here you can see that there are 16 segment, 1, 2, 3, 4, 5, 6, 7, 8 and 8, and here also 8 you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, when 1 inch is divided by 16, you will get 0.0625 inch. For more clear concept, you can see here this gap in between 5 to 6 is divided into 4 parts only. That is one by first part of the 4 part, second line of the 4 part, third line of the 4 part, and it is fourth line. So, here you will get the 1 by 4 means how many inch? 1 inch divided by 4, it is very simple. That is what? 0.25 inch. Again, it is divided into 8 part. In the same sequence, you can understand. So, 1 inch divided by 8, that will be what? 0.125 inch. And then it is divided into 16 segments. So, one segment equals, as you here before, initial condition, you will get 0.0625 inch. Okay. Okay, students. So, you have done about scale. So, doesn't matter. Scales don't see once again about it. It is very simple. Another one you have to see, that is protector. So, for protector, here you have to use your own protector, but I also will show the protector. So, here it is the protector. You can see in it easily. Just you have to count the segments between two values. So, values are given what? 0 to 10. Yes. So, in between them how many segments? So, that is their degree. If you are drawing a straight line, then that will be of what? How much degree? 180. If you are writing a straight line and then just perpendicular, that will be, here it is clear, 90 degree. Yes. But here one segment will show what? 1 degree, because the gap between 0 to 10, there is what? 10. In your scale, in your protector also it is clear. Yeah. Okay. Now, here you have got the least value of, least count of protector is 1 degree. Now, next example you have to see stopwatch. Stopwatch you have seen, and the stopwatches are of also different capacity. So here this stopwatch is showing the number given here 0, 0, 0, 0, 0. So what are they for? If any number displays here, what does it show? If any number displays here, then what do they show? And if any numbers display here, then what do they show? So they are first places for minute, next two places for second, and next two places are for 100 parts of 1 second. That is called as what? Centisecond. Okay, centi means 1 by 100. Yes, okay. And here another instrument I will show you, and at the same time you have to see two instruments here. One later it will be used, but at first you have to use ammeter. Ammeter is here. Yes, here values may not be same, but by chance you have they are not same, not similar to diagram. But here it is given 0 to what? You can see clearly 0 to what? 100. And how many segments are there? So this device shows the least count is how many milliampere. That is milliampere. Look, it is milliampere. Milliampere means 1000 part of 1 ampere. Yes, 1000 part of 1 ampere. That is milliampere. So it is further divided into 10 segments. So look here, from here to there, that is 10 segments, but gap is 0 to 100. Yes. So what will be here's value? We have to calculate, we have to find out. That will be 10 times 100. So that will be 10 milliampere. 10 milliampere means you can say 100. Milli means 10 ampere, 10 milliampere. Just let me write on the board. That will be here 0 is given and then 100 is given. And this gap is of how much? 10. Yes, so it is milliampere. And it is also what? Milliampere. Yes, and 10 times lesser. That means what will be it? 10 milliampere. Yes, one segment. So least count is what? 10 milliampere. Simply, you can change it into ampere divided by 1000. So 10 to the power, if it is divided by 1000, then what will you get? Or if you are dividing by 1000, you can write 10 to the power minus 3. Yes, then you will get 10 to the power minus 2 ampere. So in that way, you can convert also. Already you have learnt. Okay. So here in diagram, it is different from 0 to 20 milliampere. So that division is also equal to 10. So one segment shows what? 2 into 10. That means 2 milliampere. So here it is given. It is what? 0.002 ampere or 2 milliampere. Here 10 to the power minus 2 ampere for real device, but this device is little bit different. Okay. Now next, see, it is also stopwatch, but here value is different. Here hour, minute, second, and then what? Millisecond. Yes, it is. It shows more less time. That means it has more least count, or you can say very less least count. Same thing. More least count means that is very less least count. Yeah, and it is wristwatch. Wristwatch is showing what? Least count. Here in detail it is given. So sorry, here detail, hour, minute, and second. Less than second unit, you cannot measure it by using it. Here one thermometer is given. That thermometer is a mercury thermometer. Here I have, but this thermometer is, the thermometer I have is digital thermometer. So digital thermometer later I will use. Don't worry. I have digital thermometer. Later we will use it. But here in mercury thermometer, that is normal thermometer, yes. I have here laboratory thermometer. So this thermometer, you can see the unit given here. Here is given. Here, what is it? Degree Celsius. And you have to see now that just gap in between that and that. 0 to 10. 0 to 10. Yes. So there is what gap? 1, 2, 3, 4, 5. Again 5, 10. So one segment shows the value of 1 degree Celsius. So its least count is what? 1 degree Celsius. And same thing you can see here also. But here the value shown by this thermometer is a little bit different. The gap is only 5. That means one segment is not showing 1 degree. It is showing what? 2 degree centigrade is shown by it. Okay. And voltmeter, I saw you a meter from this device. This device is used to verify Ohm's law, about which we will do later. Here it is voltmeter. Look same, but it measures electric current, and that measures what? Voltage, potential difference, EMF. So here also you have to find out the gap, 0 to 1 volt, and this, the gap between 0 to 1, there are 10 segments. So 1 volt divided by 10, that is 0.1 volt is its least count. Okay. In diagram also you can see, but here it is different value, that is 0 to 2, and you have to find out yourself. It is divided into 10 parts. So one part will show what? 2 by 10, that is 0.2 volt. Yes. And here this thermometer is showing the value 36.8 degrees Celsius. So minimum you can measure. What is the minimum value given by it? You can see here, that is 0.1 degree Celsius. So what is the importance of the least count? You can understand by some events. When talking about the age of a person, year is important. For that, least count will be year. We do not mention usually days, months, that is year. When we are appearing in exam, minute is important. So there it is better to use not few times seconds also. In 30 seconds, you can do something more. You can put one answer. Yes. When we are measuring the thickness of a cup or thickness of a paper, then millimeter is important. When we are telling the distance between two cities, kilometer is important. There is meter is neglected, centimeter is neglected. And if you are talking about the distance between stars, then meters and kilometers are also neglected. Then we discuss about light year, astronomical unit, parsec, about which you have studied. Okay. Now we have to discuss about average measurement and its importance. Average measurement, you are familiar with it. You have done many times this work, just it is repetition. If the sum of the measurements taken by repeating the measurement operation and dividing it by the number of times, how many times you took the measurement, by that time you have to divide the sum total of the measurements, then you will get average measurement. Okay. For example, if a stone is dropped from a height, yes, and you are measuring the time, how long does it take to come from up to down. If you are repeating this measurement 3 to 4 times, 5 times, you can measure it. And here it is considered, firstly, we have got 2 seconds. Next time we got 1.9 second. Next time we got 2.1 second. And next time we got 1.8 second. Different values we have got. Sometimes we may get same value also, doesn't matter. But here, for example, you are given 4 different values. Then how will you find average measurement? At first, you will add all of the measurements. 2 plus 1.9 plus 2.1 plus 1.8. And then that total of the second will be divided by 4, because 4 attempts you have done. Yes. Now, after addition, you will get 7.8. You add them, 7.8 divided by 4. And when this number is divided by 4, you will get 1.95 second. So, this is the average time taken by the stone to reach the ground. In the same way, that's why we do experiments. We repeat the processes 4-5 times. It is the cause. Okay. What is its importance? Correct quantity of a measurement can be obtained by taking the average measurement. Yes, because sometimes we may get some errors, so it reduces the error. If the same kind of result is obtained repeatedly, so as I told you that sometimes we get the same result. If all the times you have got the same result, no difference, then it is called as precision or precise measurement. Okay. And the more error free a measuring device is, sometimes this difference is caused due to problem or errors in measuring device also, the more precise and accurate the measurement can be. So, if instrument is errorless, then you can get more precise and more accurate result. But remember, accuracy and precision are not the same thing. They are little bit different. Precision and accuracy, they have closely related, but meanings different. You have to understand the difference also. Accuracy refers to how close the measurement is to the correct or accepted value. Means 1 hour equals 60 seconds. If your measurement gets number of times 62 seconds, 62 seconds, 62 seconds, then that will be precise but not accurate. Accuracy, that means not near, not close to the correct value. Yes, that will be precise measurement but not accurate. Okay, so what is precise measurement? Precision refers to how close the measurement of the same object are to each other. If number of measurement are taken, then how closely, that means the values are obtained. That is called as what? Precision. So that is the difference. Yeah. So today we have studied mainly about the least count and the average measurement, which are very important in scientific measurement. And let's see how much you have learnt. Yes. So first question I am giving you. So what is the least count in the given apparatus? Here you are given a cylinder, measuring cylinder, and there are values of volume in milliliter is given, 400, 450, 500, and the gap between them is of, you can count yourself, count it. Okay. So what is the least value of the given apparatus? You have to find out yourself and compare the answer. If you have got 5 ml, that is okay, because there 50 is divided into what? 10 parts. So 50 divided by 10. Very clearly you have got it. How many meters are equivalent to 1? Is it gram? GM? No, it is what? Gigameter. Gigameter. So you have to find out how many meter is equal to 1 gigameter. Don't say gram. Per gram there should be only G, not GM. Sometimes GM is also used, but not good. That is only G. Here is gigameter. Okay. So giga, just put the value of giga. Mega, giga, tera. Yes. That is what you have got. What is it? 10 to the power 9. Okay. 3 measurement of the length of an object are 28 centimeter, 27 centimeter, and 27 centimeter. 2 are same. What is the average length of the object? You have to calculate it. Little bit calculation is required. You have to add them and then divided by what? How many attempts are there? Divide by that. And what will you get? Find out the answer. Yes, it is what? 27.33 centimeter. Now, another device is shown here. that is aneroid barometer, and the unit of pressure in the given aneroid barometer is millimeter of Hg, mm of Hg. So, what is its least count? So, for that you find out the gap given here. Yes, what is it? After that, the division you have to find out. Yes. So, what is the least count? Now, you have to calculate yourself and find that really you have got 1 mm of Hg. Yes. Okay. Now, here are a set of questions to which you have to copy. Define least count of an instrument. Write any two advantages of the least count. Define average measurement. Clear the cause of taking average measurement in experimentation process. What factors affect on accuracy and precision of any measurement? Okay. So, answer of these questions you will write in your copy, and then you will show the work to your teacher. So, students, that's all for today. We have finished this unit. Next time we will be with new unit in front of you. That's okay. Namaste.